For this video, we're going to continue looking at absolute value, but now we're going to look at absolute value inequalities. So to start with, let's review some inequalities. All right, so we have a couple of compound inequalities up here and some with variables on both sides. So for the first one, I'm going to go ahead and combine the 5n and negative 8n. So we get negative 3n plus 5 greater than or equal to 2. I'm going to subtract the 5 over, then divide by a negative 3. Remember, anytime you multiply or divide by a negative number, you have to flip your sign. So this becomes n is less than or equal to a positive 1. To graph it on a number line, I'll go to 1, and for this one, put a closed circle because it is an or equal to, and I want all the n's that are less than 1, so I'm going to shade to the left. For number 2, I'm going to subtract the x over to get the x on the same side, and subtract the 8 to get out my constants on the other side. So negative 4 minus 8 is negative 12. Divide by 2. And then I'm just going to flip everything so that my variable is first. So it's x is greater than negative 6. So I'll go to negative 6. And this time put an open circle because it's just greater than. And I want all the x's that are bigger than negative 6. So I'm going to shade to the right. For number 3, it's a compound inequality because I've got two inequality symbols and I've got my variable in the middle and two constants on the outside. It works the same way as everything else except that whatever I do to the middle, I now have to do to every section of my inequality. So whatever goes to the middle goes on the left and the right. So to get the x by itself, I'm going to subtract the 1 from all three sections. So I get negative 4 less than or equal to negative x less than or equal to 3. Then divide by a negative 1 and divide everything. Remember, when you divide by a negative, you flip all of your signs. So that means I'm going to make this a positive 4 greater than or equal to x greater than or equal to negative 3. And this, just to have good like math grammar, we want to write it with less than signs. So we want to start with the smallest boundary to the biggest. So I'm going to say negative 3 less than or equal to x less than or equal to 4. So the way we consider this x value is that we want the x's that are greater than negative 3 but less than 4. So everything between negative 3 and 4. So I'm going to put a negative 3 and a 4 on my number line. And I'm going to give them both closed circles because they're both or equal to. And I'm going to shade in the middle because I want it to be bigger than negative 3 and smaller than negative 4, or positive 4. All right, for the fourth one, I've got x is greater than or equal to 4 or x is greater than or equal to 6. So if I start by thinking about that on a number line, if I put a 4 and a 6 and I graph both of them, if x is greater than or equal to 4, that means it's going to have a closed circle, and I'm going to shade to the right. Greater than or equal to 6 is going to have a closed circle, and I'm going to shade to the right. So because they overlap each other, and I want one that falls in either category, doesn't have to be both, really I can narrow this down to just saying x is greater than or equal to 4. Because if it's greater than or equal to 4, it's also greater than or equal to 6, and it's either or. So it falls in, every part of that falls in the category that I want. For number 5, it's different. Now instead of being anything goes, I want specifically x is greater than or equal to 4 and x is less than or equal to 6. So if I graph that on a number line, put my 4 and my 6, I've got greater than or equal to 4, so my closed circle, so that's going to shade to the right, less than or equal to 6, closed circle, shade to the left. So my and is from 4 to 6. So I can rewrite it like we wrote this one up here that went negative 3 to 4 and say 4 is less than or equal to x is less than or equal to 6. And then number 6 is just solving an absolute value equation, which we've looked at already. Just a quick review. Okay, so remember I want to get my absolute value by itself, so I'm going to add 3. Then divide by 2. So I get the absolute value of x plus 5 equals 7. Remember, absolute value is a distance from 0, so it's going to be a positive value or a negative value will still give me that distance of 7. So I have x plus 5 equals positive 7, x plus 5 equals negative 7. Subtract my 5 and I get x equals 2, x equals negative 12. So my solutions are 2 and negative 12 for this absolute value equation. So continuing with absolute value inequalities, we're going to have to look for an and an or, okay, to figure out which is which. And if you think about it, because remember absolute value is distance from 0, so for this one I want the absolute value of x, so the distance from 0, to be less than or equal to 4. So that means if I were to think about it on a number line, I want to be within 4 units from 0. So that means that I'm okay from negative 4 to positive 4, but it can't be outside of that section. So that means I would be going from here to here. So this one, when we graphed it on the first slide over here, is my and, right? Because it's got to be greater than 4 and less than 6. So I'm being very picky, and I want it to be right in between those. So less than is going to be and. Right? Then I want the absolute value or the distance from 0 to be greater than 5. Right? So that means I'm working with negative 5 to positive 5. I want it to be more than 5 units away from 0. So that means open circle because it's just greater than. But I'm going to be going away. Because negative 5, negative 6, and negative 10, and so on, that's getting farther from 0. And then 5, 6, 7, 8, and so on is getting farther from 0. So this one, because they don't overlap, there is no and, this one's going to be the or. Because it works if it's this way or if it's this way. All right? One way that we can remember it is that less than and then great or. All right, less than and great or. Okay, so now there's a couple tricks when we actually do our absolute value inequalities whenever we start to simplify them. Just like with our equations, we want the absolute value to be by itself. So for the first one, my absolute value is by itself. The absolute value of 3x minus 6 is less than or equal to 15. For the next one, I'm going to go ahead and add the 3 and then divide by 2. This part doesn't go away. I still need to get the absolute value by itself. Now for the first one, the absolute value of 3x minus 6, all right, that needs to be less than 15. So that distance has to be less than 15 units from 0. So that means that I can put a negative 15 on one side, a positive 15 on the other, and I want that 3x minus 6 to be in the middle. So if it's an and equation because it's less than, that means I'm going to put it in the middle and make a compound inequality every time. Then to solve, I'm just going to add 6 to all three sides. So I get negative 9 less than or equal to 3x less than or equal to 21. And then divide everything by 3. And I get negative 3 less than or equal to x less than or equal to 7. And that is my solution to this inequality. So as long as x is between negative 3 and 7, my absolute value is less than or equal to 15 units from 0. So and becomes our compound inequality where I have two separate sides, positive and a negative. The or is a little different, right? So that means that remember if we go back to my number line, if I want to be more than 4 units away, that means I want to be left of negative 4, so less than negative 4, or to the right of 4, greater than 4. So I'm going to write those two inequalities. I have x minus 2 needs to be less than negative 4, or x minus 2 can be greater than positive 4, and both of those scenarios would work. So and you write one big inequality, or you're going to have two separates. You're going to have the less than the smaller, greater than the bigger. So then if I want to solve, I'm just going to add 2. So I get x is less than negative 2, or add the 2 over here, x is greater than 6. So if x is less than negative 2, or x is greater than 6, that means that it will work for my inequality up here and make it to where it's greater than 5 and all of that. So for and, one big inequality, or two separate, and you have to think I want less than the negative 4 and more than the positive 4. So it's going to be either or. If I wanted to graph these, this one's got both closed circles, and I shade in the middle. This one's got both open circles because it's just greater than and less than, and I want less than negative 2, greater than 6. So there's my graph on a number line.